Okay, so what will happen is when you create a thread, right? So it will be in a new state. Okay, now from new, when you do a submit of that thread, it will go into the runnable state. Okay, runnable means this is handled by thread scheduler. Okay, backed by the few algorithms like round robin, FIFO, LIFO, and whatever. Okay, now the thread scheduler will be monitoring the details like who we should get executed and all, and then from here it will go to the running state. Okay, now from running there can be two things. It can either go back to the runnable state because their time was up, and then he said, okay, now another thread should get a chance, you go back to the runnable, or it can go to one state which is called the blocked or waiting. Okay, and from there it can again go back to the runnable state, and finally it will go to the terminated state. This is like done. I know this is like once it is terminated, it can't go back to any of these states. Okay, now so you have submitted this to thread schedulers, and thread scheduler said, okay, fine, there are T1, T2, and T3. So when I did a submit of T1, T2, and T3, all these threads came into the runnable state, and now it is managed by the thread scheduler. So thread scheduler may be maintaining a queue or maintaining whatever for round robin circle kind of thing, and then they do that whatever ways, right? And then say, okay, fine, now T1 will get into the running state. So the thread scheduler said, okay, so I'm just writing here, so T1 and T2 and T3, there are three threads, and let's write it here, running state. Now it said, okay, fine, T1 will or T2 first will get. It's not even guaranteed that T1 only will get the chance. Okay, so maybe suppose T2 got the chance and said, okay, T2 will start running. So T2 said, okay, fine, and what I need to do, I need to print from 1 to 15. So I started printing 1, 2, 3, 4. As soon as it printed 4, it still need to go till 15, right? Thread scheduler say, okay, enough, you got enough chance. Now you come back to our this one, and so T2 will again join back the queue, and T1 will get allocated. So suppose this printed a little faster, it reached here, then T1 will get back to the queue again, and then T3 may be getting a chance, and then T2 1 and 2 only printed, then again it moved back here, and then again T2 got the chance. It will continue from 4. It will continue after 4, so it will print 5, 6, 7, 8, 9, and then again it will move back to the queue, right? And then it will. So this is how it will happen. And in this way, what happens is when T2 was running, and suddenly T2 was thrown back to the runnable state, T1 got the opportunity, and again after some time T2 came back. That is what we call the context switching, which means we are changing the context of the execution as the thread changes, and these data are actually kept into the thread local. So they know that there are thread local variables which basically keeps track of these counters, variables, values, to what we have printed and all that. And once that instruction completes, finishes, then it will move to the terminated state. So this is the flow: new, runnable, running, and terminated. But there is one more state, which is the blocked state. Can somebody speak about the blocked state or waiting state? Anyone?
Yeah, so suppose thread got interrupted or it didn't find some resources, like it will go to block, and for certain period we want to make it wait or something like that, then it will go to block.
Absolutely. So if we want to do some intentional wait, that okay, fine, I don't want you to run for some time. I want you to just go and wait for something, and until unless I notify you, you will remain in that state. Okay, so that happens through something called the thread internal communication. Thread inter communication, and there are a few methods which we use: wait, notify, notify all. Again, these are the methods or the signals. We call it as a signals. We send those signals to those threads that, okay, hey, I think, I'll give you the perfect example. I think these producers and consumers program, I had asked you guys to write it. That is the best way to use this thread communication. And a lot of time, company asks you to implement that as well. Hey, can you write a particular queue where producers can keep producing and consumer will wait for if the queue is empty. Remember that. So if that code will have something like, if you have a queue, right, and there are n number of producers producing it, or suppose whatever, one producer is producing it or n number of producers producing it, you can produce till the queue is not full. If the queue is full, what we will do is we will put a wait on that particular thread, on the producer thread, and we'll say that, okay guys, whenever the queue becomes empty or there is a space in the queue, I will notify you, stop producing the data. So you have sent a signal to that thread that wait. When you did a wait, that particular thread will not move to runnable, it will move to the blocked state, waiting state. And it will remain in the blocked state or waiting state until unless somebody actually goes and tell them that now you can move back to the runnable state. And that we do through the notify or notify all. We'll talk about the differences, notify all. But notify will do is what? It will tell that, okay, now, now suppose the consumer has consumed few data and now I want to notify it. Then I'll call a notify method on that particular thread, and that particular thread will come back to the runnable state and they can start producing the data back to the queue. Okay, so that is what we call the thread intercommunications, and that is how it happens. There is another method which is a join method. We'll talk about that later, but I don't want to go in that deep as well. But so inter-thread communication is something which basically gives you the flexibility where you can wait, notify, and you can have a better control over your threads in that way. Okay, so let's see the example here and then we'll understand it. Okay, so now once we do this start, that's it. My control is over. There is nothing I can do as of now. Okay, what it'll do is it will submit T1, T2, and T3. Now it is at the mercy of thread scheduler. Know how it wants to trigger it, whether it give the allocations to T1, T2, or T3. It depends on them, right? So let's execute it and see the data. What is it? I think I've opened this IntelliJ after a long time, so it just taking a little while. It will not take from next. Okay. Now you see here. So first thread got allocated. That's fine. So 1 is printed by first thread. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So in this case, thread 1 was lucky. Okay. This will not happen again if I try again. We'll see that. But it got lucky that it got that much window to print from 1 to 15. Okay. But this guy was not lucky. Okay. If you see the second thread printed 1, 2, 3, 4. Right. And then it said, okay, boss, enough time. You need to give the other threads also a chance to go and get their work done. So second thread was kicked out when the value till what printed was 4, right? So next time the second thread will come, what value it will start printing?
5.
5, right? So that will be stored in the thread local memory, in the process. Now, third thread got a chance. So it has printed 1 and 2 only. And then it said, okay, boss, enough. Let's give a chance to the other thread again. So again, second thread got the opportunity and it could print only 5. Again, it kicked out, and third thread got the chance and it printed 3. Then again, it kicked out, and you can see the behavior here, right? So if I run it again, it might that the first thread which got the, 1 second. It's printing again. Okay. Okay. Now, if you see here, oh, still first thread is this fine? Maybe my system is much faster. I don't know, but that's not something which you'll always expect it to be. Okay. If I increase the range to 20, 25, it might happen that the first thread will get interrupted, but so far it hasn't happened. But I understand that you guys have understood the behavior of the thread, right? So there are 3 threads here. If I increase more and more, the context switching will become much and more, right? So if I add 3 more threads or 2 to 3 more threads, in that case, what will happen is the context switching right now, which is happening only between, okay, right now, what are the context switching happening between which all threads? Context switchings between which threads are happening?
2 and 3.
2 and 3 only, right? So if I increase more, if I increase 3 more threads, we might see that there are much more context threads starts happening, right? Let's see that once more. 2 more will add it. Just see the variability of this. Okay, T4, T5, and then T4 and T5. Okay, now you see that, right? Now the first thread has printed 1, and it didn't get a chance to print the numbers which it was printing till 1 to 15, because now the competition has become more, and it is a rare scenario that thread 1 will get that longer window to print 1 to 15, and it was just kicked out only after printing 1, and third thread got a chance, and then you can see that it's behaving like a different way now, right? So the content, what happened to that? Why it's okay, whatever. So we can see that the more number of threads I am creating, the context switching is becoming more and more, right? And the window which it gets is pretty less, and that's where if you have more and more more and more cores, your threads will get more and more chances, and there will be a less context switching. So the context switching is bad. It is not considered as a good thing, right? But there is no other way to avoid that. You can only simplify it having by more and more cores, so that one thread can last a little longer, so that it can finish it. Because when you do a context switching, there are a lot of things happens. It writes the data to the memory register for thread local, and then it stores all the information till what and snapshot of the data and everything, and then it kick out the first thread and then brings in another thread, then again loads all their data and then do that. So the context switching actually defeats the purpose of having the high throughput, but it solves you the problem that only one particular process will not be getting more priority and the other will not get much. So those starvations will not happen. The sequential nature will go away, and everybody will feel like, I have done, it is my own system. So when I print this 1 to 15, you will see that almost everybody gets completed at a similar point of time. So that is one thing I'll show you. Just to give me a second. So if you see here, 15 was printed by first thread here, second here, the third one here, right? Fourth one here. So pretty much what will happen is there will not be much difference in the time when it finishes. So it will be like an average time with which all the 5 threads will be completed. There could be some here and there, but for the outside world, like if 5 people tries to log in to the same system, and if it creates 5 threads, right? So you have created one web applications, and there are 5 people tries to log in at the same time. What happens? Your web server creates 5 thread, right? And those 5 threads does what? All each one of them takes your username, password, and whatever, and it does the authentication against the database. Now imagine if it has been a sequential, whoever would have got into the system first that should get completed. That let's go check the connection to the database, get the data, check it, and then say the success. Then comes to the second request, which was sent by some other people sitting in US. Third will be in Singapore. So now imagine that you'll have to wait, and more number of people starts logging in, the more latency you're creating, and the person who joins a little later, that will be waiting forever kind of thing. But in case of a thread, what happens? If you give 20 requests, it creates 20 threads, and it bombards, not bombards, basically scatters the request, and then it does that context switching and utilize the code to the maximum throughput, and then works in that way. So basically everybody feels that it's their own system, and they don't get starved, they don't wait forever, and the response time is pretty much similar. So if you open 2 systems and you log into the Facebook, pretty much you will feel the same thing, that you are logging in. But actually, if it goes, suppose that is not the ideal case, that both the requests will go to the same server, because we have a load balancer, and then you'll have a tens and hundreds of systems running. But just think about it, that just think about a hypothetical case where 2 requests from 2 laptops at the same place goes into the same system, then also you will not feel the difference because of the thread. Did you guys understand the advantages of using the thread and how it actually works? Any questions so far?
Diwakar, what did you say about that context switching, like between threads? What's the issue there?
See, the context switching is nothing but, so you have one core, right, where the execution happens, where that 1 to 15 print is happening. Suppose think about the printer, okay? There is a printer which will print from 1 to 15 pages, right? And there are 5 threads which want to print, correct? Now, if I do in sequential way, first person will print, then the second person will come, then the third person will come. But in case of a thread, what happens? The first person will come, they will print 3 pages, right? And they will wait. They'll say, okay, I'll be sideways, and then they give the chance to second person. They will also print 2 to 3 prints, and then that will come aside, and then the third one will get time, and that way they'll keep on doing it. What will happen? They will all finish there at an average time. It's not like one person has printed everything and then left, right? So the context switching is that the first person has printed 3 pages and it has come out, they will come out with something, right? Because they will have to remember till what print they have done, right? From where they have to start. And then once again they get a chance, then again they will bring in all the informations and data to the printer, and then they'll start doing it. That is what the context switching means.